We'll now do a demonstration to show how we can calculate the amount of oxygen in air. I have some steel wool, and I'm going to put the steel wool in a solution of acetic acid in water, commonly known as vinegar. And that's just to let the steel wool become a little bit more reactive. We'll let that sit for a few minutes, and then we will put the steel wool in a graduated cylinder. So after about 5 minutes, I took the steel wool out of the vinegar and shook off any excess solution. Now place some of that steel wool in a graduated cylinder and just push it all the way down to the bottom. I'll take the bottom off, and then we'll set the cylinder upside down in a beaker of water. We'll now let the apparatus stand like this overnight, maybe even longer. It doesn't matter how long it stays. It should stay at least 24 hours or so. During that time, the oxygen that's in the cylinder, that's now trapped in the cylinder by the water, will react with the iron, the steel wool, to form solid iron oxide. And so the oxygen that's in here will react. The water level that's in the cylinder should then go up as the reaction proceeds and as the oxygen is used up. After standing overnight, the water level has moved up in the cylinder. You can see the new water level right here. What has happened is that the oxygen that's in here has reacted with the steel wool up in the top, and that has formed solid iron oxide, and as a result the volume inside here is decreased, drawing the water up. What we'll now do is to add water to the beaker so that the water level is the same inside as outside the cylinder. This way we know that the pressure inside and outside will be the same. I now take a ruler and I measure the length of my cone. So the cylinder itself has a length of about 24.5 centimeters, and the water has risen about 6.0 centimeters. So here are the numbers. The length of the cylinder, 24.5 centimeters. The water level has risen 6 centimeters, which then corresponds to the amount of oxygen that has been consumed. And therefore the percentage of oxygen would work out to be 6 over the 24.5 centimeters times 100, or about 24%. This number is a little bit high. The normal percentage of oxygen is 21% in dry air, but we haven't taken into consideration either the amount of iron in here, the steel wool, and so this gives us a rough value of the amount of oxygen that's present in the air. It's a number that students should be familiar with because we all breathe air, and so the percentage of oxygen is an important